Welcome to qnawire.
Here we have a clamshell bucket that is being pulled upwards, which means it will close. So these points D and E will get closer together and theta will shrink. We want to find omega, so the angular velocity here, when theta is 45 degrees and this bucket is closing as it's being pulled upwards at that rate. So what we want to do is find a bunch of angles here. So we know the angle DCE, or theta, is just 45 degrees. We know the angle FCE will just be half of that, which will be 22.5 degrees. We know the angle OCB, which you can see in the top portion here. Angle OCB will have to equal 180 degrees minus 90 degrees, which is over on the right here, minus the 22.5 degrees for FCE, which would leave us with 67.5 degrees there. From that OCB triangle, then, we can look at the length of CB divided by the sine of that alpha angle would equal the length of OB divided by the sine of the OCB angle. This is just the law of sines. And we can use this to find that alpha equals 50.35 degrees, where I just did the algebra multiplying the sine of alpha over, dividing everything else over, and taking the inverse sine. So once we have that angle, we can draw a velocity diagram here, where we'll draw a new triangle quick here. We'll have the velocity of C, which is going upwards at a slight angle here. We'll have the velocity of B to the right, and we'll have the velocity of B given C, which will then be down and to the left. So B given C, velocity of B, and velocity of C. So all of our angles, the angle at the bottom left is just 90 minus that alpha. The angle at the top right, which I didn't quite leave enough room to write these cleanly, is just theta over 2. And the angle at the bottom right is just beta. Or we can use the sine rule again here. So we have VC divided by the sine of beta equals VB given C, or with respect to C, divided by the sine of 90 minus that alpha. Sorry, I hit a button here on accident. So then we would like to solve this for VB given C using all the angles we already have. And we would find that VB given C. So we also need to know the velocity of C is just going to be the velocity moving upwards here. So that's that 0.5 meters per second. Will give us 0.361 meters per second. We can then find the angular velocity for that bucket. Omega equals VB with respect to C divided by the length between them, which is 0.5 meters, that's R, which gives us 0.721 to 2 radians per second.